everyone. In this lecture, we will see what is problem solving and problem formulation. When we think of intelligence, human or artificial, much of it boils down to the ability to identify problems, analyze them, and find solutions effectively. So, AI at its heart is about creating agents that do just that. Okay. So, throughout this session, we will understand how AI systems perceive problems, the processes they use to solve them, and how we humans design and formulate problems so machines can handle them. So, what is problem in AI terms? Imagine standing at point here, and your goal is to reach point there. Okay. So you put your starting point and you know your destination, but the path is not immediately obvious. You need to figure out a sequence of actions to get from one to the other. So problem solving involves making optimal use of the knowledge and information to select a set of actions that will bridge the gap. Problems can come from everyday experiences like figuring out how to reach the airport on time, academic domains, it is like solving a math problem, games and puzzles like chess or crosswords. So, no matter the context, problem solving is fundamentally about finding a path through uncertainty. Okay, so let's reflect more deeply in this. Problem solving, especially in AI, is about searching, that is, searching through possibilities, through paths, through actions. A good AI agent doesn't just randomly try things, it reasons, predicts outcomes, considers constraints, and then chooses actions intelligently. Thus, problem solving in AI is deliberate, systematic search through a space of possible actions to reach a defined goal. So, how does AI approach problem solving? It models the world as a set of states. The initial state it represents where we start, goal state represents where we want to reach, actions move us from one state to another. AI uses algorithms to find a sequence of actions that transforms the initial state into the goal state while considering efficiency, resource limits, and potential uncertainties. So AI does not know everything in advance. It must often plan, search, and adapt. For instance, in a chess game, the AI must look several moves ahead, but anticipate the opponent's moves and adjust its plan dynamically. Thus, AI's problem solving is dynamic, recursive, and strategic. It's not about finding any path, but about finding the best possible path under the circumstances. Right? So here we have a structured, well structured, that is structured problems. So structured problems has well structured problems and ill structured problems. So this is these structured problems. These problems are more organized than others. They have clearly defined starting points, clear goals, known actions, and outcomes. So examples which include games like chess, where the rules are complete and known. When the problems are structured, it's easier for AI to model the environment and find solutions. But many real world problems are unstructured, that is, incomplete information, unexpected obstacles, unknown variables. Handling these is much harder. Okay, so this the structured problems examples. Now let's break down the problem solving process step by step. Problem solving is not random, it follows a process. That is, problem definition is what exactly are we trying to solve? And problem analysis and representation is how do we model it? Which elements are important? Planning what stage a strategy will be used to search for a solution. And execution is carrying out the steps we have planned. Evaluation is checking if the solution works. Consolidating gains is learning from the process to improve future performance. AI systems use this cycle repeatedly, refining their actions with each attempt. Okay. So problem solving falls into two broad categories: general purpose problem solving and special purpose problem solving. So general purpose problem solving where techniques like means in analysis are applied here. The AI compares the current state to the goal state, detects differences and chooses actions to reduce those differences. For example, if you are late for a flight, you choose the fastest mode of transport. And next is a special purpose problem solving. So these are customized for specific domains with unique characteristics like classifying legal documents based on cases. So different problems demand different strategies here. So let's revisit the core technique of the AI problem solving. So I define the problem accurately, represent it effectively using models like graphs or trees, plan using search strategies, execute solutions, and evaluate and learn from the results. A search algorithm typically underpins this process. It takes a problem as input and outputs a solution sequence. Okay. So in practice, this can involve complex processes including probabilistic reasoning, heuristics, and optimization. And the steps involved in formulating the problems. When formulating problems, key steps include identifying the problem precisely, defining the problem boundaries, modeling the environment, that is, the states, actions, and goals, choosing appropriate representations, graphs, state spaces, logical formulas. So, good problem formulation is critical. Poorly defined problems lead to poor solutions. So, here problem identification and definition, where this is a foundational one. Identifying a problem means recognizing that there is a gap between the current and desired states. And defining that is definition means specifying this gap clearly and realistically, ensuring that the problem is solvable within given constraints. Without good identification and definition, the AI system might solve the wrong problem or waste resources chasing irrelevant goals. So in AI, problem space is the universe of all possible states and actions for a problem. Task knowledge refers to what the agent knows about the domain, what actions are possible, how actions transform the state. So together they form the playground in which AI searches for solutions. So good modeling of problem space and task knowledge makes solving far more efficient. The state space is more formal concept. It's a graph where nodes represent the states, edges represent the actions leading from one state to another. Navigating the state space is the essence of problem solving. So some problems have huge state spaces like chess with billions of possible positions, which makes efficient searching a key challenge. Next, let's take a practical example. Suppose you want to plan a route from your home to college. Okay, so this is an example where three cells in the four cell board are filled with single digits and one cell is left blank here. So the game is to change positions of the digit and blank cell of the board to arrive at new board positions. So the rule of the game is blank cell can change the position with a digit by horizontal or vertical movement. Okay, so that's an example where here you can take an analogy like this. The initial state is at home, goal state is at college. Actions are walk, bus, taxi, bike ride, etc. So like this. So constraints are cost, time, weather conditions. You model this as a state space and search for the best sequence of actions. Perhaps walk to bus stop, take bus, walk to college. So this simple example mirrors how AI agents solve the complex problems, right? So problem solving in AI is almost always tied to algorithms. Algorithms guide the search, that is uninformed search like breadth first search, informed search like A star, heuristic search and many more. So choosing or designing the right algorithm is critical for solving problems efficiently. Next, when formulating the problems, we decide what are the states, what are the actions, what constitutes a goal. Goal formulation must consider desirability factors. Not all ways of reaching the goal are equally good. Good formulation is a thoughtful process, not mechanical but strategic one. So measuring performance in problem solving, which involves checking if a solution was found, checking how good the solution is based on the path cost, or measuring search cost, time and memory use. So abstraction is a critical tool. It removes unnecessary details to focus the search on essential elements, improving the efficiency. So ultimately, problem solving boils down to moving from the initial state to goal state through a well chosen path of actions. So here, this journey is what AI is designed to plan and execute with minimal human intervention. Okay, this is one of the example. And finally, there are types of problems based on the knowledge. Single state problems, this full knowledge, the agent knows exactly what its actions will do. And then next is multiple state problems, uncertainty. So the agent must reason about possible set of states. Contingency problems, the agent must plan for multiple possible futures. Exploration problems, the agent must discover unknown environments before solving the task. Okay. Understanding these types is crucial for choosing the right solving strategies. So, problem solving is the soul of artificial intelligence, whether it's a robot navigating a zone or a chatbot answering customer queries. The ability to define problems, plan actions, and find solutions is what makes an agent truly intelligent. Okay, so thank you.